Hello again, John Polansky from LaSEINE. I'm an assistant professor here at Kyutech, and we left off talking about the atomic oxygen chamber. I was describing how atomic oxygen, a very chemically reactive gas, can have a very negative effect on spacecraft materials in low Earth orbit. So this is the chamber behind me, and first I'll just mention that we use a laser to generate the atomic oxygen and a mass spectrometer to analyze it, and then we set up our experimental. We set up our experiment here. One thing that's important to note is that the velocity here is well represents the ion velocity in low Earth orbit, and that velocity is about the spacecraft velocity. The spacecraft in low Earth orbit is moving very rapidly based on its low orbital altitude. So we have a relative velocity of this with respect to the ions, which have a low thermal velocity. So this chamber is a very unique chamber. There are only a few chambers capable of this in the world, actually. And we see here the laser that's used for the atomic oxygen, and then we see the path, the flow path, and finally the experimental section of this chamber. So here we really look at material degradation. That's the primary objective of this chamber at the moment. Similarly to the other chambers, if you would like any additional information on specifications or experiments that have been done or will be done in this chamber, or if you'd like to potentially work with us, just contact me or someone from our laboratory. Next, just to the left, we'll take a look at what we call the general purpose chamber. If you've been paying close attention, you'll have noticed that for the most part so far we've used turbomolecular pumps for the ultimate vacuum for our primary chambers. This chamber actually uses a diffusion pump. So we use hot oil vapor to capture air molecules inside the chamber to reach our simulated vacuum, our simulated space environment. This is important because we can, in some ways, contaminate the interior of this chamber and not risk damaging our pumps and our chamber. For example, I work sometimes on dusty plasma and lunar dust charging, and the dust environment can be very problematic for a turbomolecular pump or a cryogenic pump due to damage to the pump system themselves. For diffusion pumps, it's not really a problem. If we do contaminate the oil, we could change it. And we use this chamber for a number of things. We can, for example, I think recently there was a test on micro thruster that we're building for our satellite project in this chamber because we have high voltage and high current feed-throughs to simulate a high voltage thruster. But we also use it for dust experiments. And in that case, we install some sort of plasma source, an electron source, or some other plasma source to charge the dust and make measurements. So let's now move to a few other chambers that we have, which are highly specialized. And for those chambers, I'm actually going to turn this over to one of my colleagues, Dr. Khan, who should be arriving shortly to discuss his primary chamber and another chamber that we recently installed in the laboratory. Thank you.